I say, what's chapter 9 about? Chapter 9 is the same as chapter 7, confidence intervals, and chapter 8, hypothesis testing. The only difference really is that the formulas get uglier. To me, that's the main difference. Okay? So this is the work we did last time. It's all on one page here. You have it in your notes, okay? But again, just so you know what this was chapter 9, and this was inferences about two proportions. The big difference is, you guys just took the quiz just now, right? And you had to figure out, you would test a claim about P or about mu. I think that's all we have, right? Today, we're going to be comparing two different populations, P1 and P2. Right? And so here is my 3-minute review of everything on this slide, on this piece of paper. Just to kind of refresh what we did. Remember, this data is all about airbags and fatalities. So we were going to use the p-value method, and we were going to use 0.05, I think, as the hypothesis testing. Let me go back. Yep, use a 0.05 significance level. So they worked through what H0 and H1 were, right? And they said P1 is less than P2 is going to be the alternative hypothesis, because that was really the original claim, was that one population, one fatality rate was smaller than the other. Okay? Hey guys, for your homework tonight, here's a hint. Hint number 1, I guess, which I think helps. Here's our work down here when we did the work on the claims. I did write what they did. Alternative hypothesis P1 less than P2. I wrote that. But remember, if you do just a little bit of algebra, you can write P1 minus P2 is less than 0, or P1 minus P2 is equal 0. You guys remember doing that? If you do that, that'll help you when you go to plug into this big ugly formula. That's going to become a 0. Okay? So I think it's neater what they did than what we did. I remember this P bar, this pooled sample proportion, that gets used in the formula. Yeah, like I said, big ugly formula. Here's their work. Notice the 0 showing up here. That's what I was just talking about. Okay? Wow, it's so ugly it can't even fit on the screen. There's the rest of it. Yeah, okay. But this fits. This was a left-tailed test because it was P1 less than P2. And they computed the p-value and they got 2%. And since 2% is less than 5%, what do we say?
It's less than, you said?
Well, this is less than, see, the p-value is 0.02.
Then the null.
Right, p is low, so the null must go. Right? Now, what we didn't do, I was looking at my work. And I was a little unhappy. Because in my work, it looks to me like at the very bottom, let me zoom in here, guys, so you could actually see this. Okay, all of this looks good. Whoa. We got a z value. Did I do it on the next page, maybe? Oh, I did it. Good. This is what you need. So I just kept working on the next page. P was low, so we did reject the null hypothesis, and then you have to state your final conclusion in English. This is, for some of you guys, this is the tough part now, is going from English to math or math to English. Right? Very first quiz question today. Most Americans support da 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 da. Right? How do you handle that? Well, that's one of these claims where we're talking about a proportion, right? And if we say most, another word for that is majority, right? The book talked about. The claim is that P is greater than what? 50%. Right? Again, English to math. Math to English. That's part of the trick of statistics is can you not only work with numbers, but can you do something with them? Can you make claims or reject claims, right? Okay. Here is why I wanted to talk for a few minutes today. Not so much that we need to go over that again, but this. Right here. We're going to do the same data, the same problem. And we're going to test the claim a different way now. The claim was that airbags reduce fatality rates, right? And we did it with the hypothesis test. You should know that there's two ways to do it, right? You can do it with the p-value method or you can do it with the critical value. But now there's another way you can test claims between two populations, and that's with a confidence interval. And the confidence interval doesn't always give you the same exact result. But one thing the confidence interval does is it can tell you kind of, okay, not only are the two population proportions different, but how far apart are they? Okay? So again, we've done confidence intervals, right? It's just what's going to happen. The formulas are going to get ugly, right? Chapter 7, confidence interval, we had P was between P hat plus E and P hat minus E. What do you think I'm going to have in between in Chapter 9? Not just P. Well, mu is in Chapter 7 also. No, what we're going to do now is we're going to do two populations. And so instead of P, I'm going to have like P1 minus P2 between some things. Does that make sense to you guys? It's going to be P1 hat minus P2 hat plus E, right? Etc. We're playing the same game, but we have uglier formulas because we have two populations. So we're going to go through this quickly because it's time to get out of here. You guys are tired. Check out that margin of error formula, E. Woo-wee! They worked out E for me. Hey guys, there's a reason that I decided for Chapter 9, part of your final project, which is all about technology, there comes a point where, you know what, I really don't feel like writing all this out anymore. You know, I want to use technology to compute the margin of error. Okay. Well, there comes a point for everybody. And I feel like 2 weeks ago, I needed you guys to write some things out to understand what's behind it. If I just walked in and said, hey, press the magic button, I'm teaching magic. But I want to teach mathematics, right? But we understand now, and it's like, okay, I know what a margin of error is from Chapter 7. There's my formula to compute it. Look, guys, the formulas were so ugly, although here's not bad. P1 minus P2 is between these two numbers. But look at the slide up above. Whoever made this one, this was not me. I mean, they had trouble even writing it on one line, right? I just think it's kind of funny. So they worked this out. Hey, maybe two more things to say. You guys will notice this line here. See that in gray? The confidence level of 90% is comparable to the significance level of alpha equals 0.05. Why is that? I need a picture to show you. You guys, when we did the hypothesis test, I remember H1, the alternative claim was that P1 minus P2 is less than 0, right? Guys, is that a one-tailed test or a two-tailed test?
That is a one.
It certainly is, right? And since it's a less than, I'm thinking about a critical region over here, right? Well, guys, if you're going to do a confidence interval test, and by the way, what's the area of the critical region? I remember that the area of the critical region is also called the significance level. Alpha in this problem was 0.05, right? Well, if you're going to do a confidence interval, here's the story. Confidence intervals, you may remember, it's been a while, but they are always two-tailed, right? Always two-tailed. And so what we do here is we say, well, if we want to kind of match up and test the claim that we did before, I still want this to be 0.05. But because it's two-tailed, I'll put another 0.05 over here. And so what kind of confidence interval matches? A 90% confidence interval. And that's why they're doing it. You'll see that in the book when you look at the homework. Okay? So I guess the thing to tell you about tonight, how do we read this final conclusion? Here's the big deal, guys. See how they say P1 minus P2 is between two negative numbers? That's different than if it's between a negative and a positive. If it's between two negatives, here's the big punchline. They do not contain 0. And if your confidence interval doesn't contain 0, that means that P1 is different than P2. Okay? That's. You want the numbers?
No, the equation.
Yeah, the equation? Yeah. I will, but I'm going to let people out of here too because we're out of time, okay? So, anyways.